welcome to everything you need to know about the cosine rule for GCSE Maths. Now, before we get started, we need to familiarise ourselves with this sort of triangle notation here. So I've annotated this triangle here. The capital letters indicate the corners of the triangle, the angle and the angles, and the lowercase letters indicate the lengths of the sides opposite. So, for example, A is the length of the side opposite the angle capital A, and so on and so forth with capital B, lowercase b, capital C, lowercase c. Now the cosine rule is above, and it relates the lengths of a triangle to each other and a specific angle. Now what I'm first going to do here is I'm going to show you where the cosine rule comes from. I'm going to prove the cosine rule to you. And while this isn't something you'll be assessed on, it's really important that you study this and you try your best to understand it, because not only will it improve your fundamental understanding of the topic, it will also probably be quite satisfying and prove to make the learning process a lot more fun. Not only that, but it will also consolidate other knowledge that you should already have, like Pythagoras' theorem in this case. So I'm going to do that now. I'm going to prove to you the cosine rule. I'm going to show you where this thing comes from. So what I'm going to do first is I'm going to draw a line coming straight down from this corner, thus making two right-angled triangles. This one and this one. Now, we're going to call the length of this length here h. And we're going to call the length of this x. This length here. And so the length of this length here must be b minus x. Cool. So now using Pythagoras' theorem, we're gonna get from this right triangle here that a squared is equal to h squared plus b minus x squared. That's quite a lousy bracket, but you understand. And we're going to do the same with this triangle on the left. Using Pythagoras' theorem, c squared is equal to h squared plus x squared. And on this second equation here, I'm just going to make h squared the subject. So h squared is equal to c squared minus x squared. Now, what I'm going to do is I'm going to plug this equation, I'm going to plug the h squared we have here and substitute it into this one. So a squared is equal to c squared minus x squared plus b minus x squared, because h squared is the same as c minus x squared. I've just substituted it. Okay, let's simplify this. So we've got a squared equals c squared minus x squared. If we expand this bracket here, we're going to get b squared. We're going to get minus 2bx, and then an additional x squared. So we can simplify this. This minus x squared and this positive x squared are going to cancel. And so we're going to be left with a squared equals b squared plus c squared minus 2bx. Now you're already seeing we're sort of getting there. We're sort of close. But let's look a bit deeper. Let's see what x is. So x is obviously this length here, but we're going to use SOHCAHTOA to find an equivalent expression for x. So if you notice, if we take the angle A, if we take cos, the cosine of the angle A, this is going to be equal to the adjacent over the hypotenuse because of SOHCAHTOA. So the adjacent side is x itself, and the hypotenuse is c in this triangle here. And so cos A is equal to x over c, and so c times cos A is equal to x. And so we can make that substitution into this equation here. So a squared equals b squared plus c squared minus 2bc cos A. And that's where the cosine rule comes from. Okay, so we're now, and what we can also do, if I scroll down, is we can also rearrange the cosine rule so that the subject of the equation is cos of A. Because this currently the subject of the equation is a length, it's A. And so you plug ideas, you'll have B, C, and the angle capital A, and you'll figure out A. But let's say you wanted to figure out the angle, and you had all the sides. Well, we can rearrange this formula. So if we add 2bc cos A onto both sides, what will we get? 2bc cos A add A squared equals b squared plus c squared. We can take away A squared, 2bc cos A equals b squared plus c squared minus A squared, and we can divide by 2bc, giving us an equivalent form of the cosine rule. Cos A is equal to b squared plus c squared minus A squared over 2bc. So you can use either or. You can use either of these versions. Dependent on the question. So what we're going to look into now is applications of the cosine rule. We're going to try and apply the cosine rule to exam questions. Also notice that when we're applying the cosine rule here, these letters are arbitrary. They could be any way round. Like we could also have, if we get our eraser here, we could rub out this B, rub out this A, this C, and we can put the letters in different places. So instead of B being up here, we could have A up here. We could have C over here, and we could have B here. All that would change is that obviously the lowercase b still has to be on the opposite side of this one. Lowercase a has to be on the opposite side. Lowercase c has to be on the opposite side. So it doesn't really matter what order it is in. And so you could change this formula here if you wanted, and you could have b. You could have the b length as the subject. So you could have b squared equals a squared plus c squared minus 2ac cos capital B. So you can rearrange these letters so long as you're consistent with it. So here, A is in the subject, so A is not in here, and A is here. Here, B is the subject, and so B is not in here, but B is here. The numbers are arbitrary, and so when we're applying these equations, you can do it any way you like. Okay, now we're going to look at a couple of questions. Feel free to pause the video and give these questions a go. But in our first example, here we are given a triangle, we're given one angle, two sides, and we're trying to figure out the third side. This is perfect for using this equation here. So we can choose b to be 13. We can choose our c to be 10. We can choose our a to be x. This is what we're trying to figure out. And if a is x, then 100 is going to be capital A. So our capital A, our angle A, is going to be 100 degrees. And so, I'm going to need my calculator for this one. I didn't realise. Okay. So, if we plug this into the cosine rule here, we know that x squared is equal to 13 squared plus 10 squared minus 2 times 13 times 10 cos 100. We know that this is true. So you can then get your calculator and figure this out. Where is my calculator? Hold on. No cuts, no edits. No cuts, no edits. There we go, got it. Thanks for bearing with me. Okay. So, 13 squared. I could have probably done that in my head, but you got to be safe. 13 squared is 169. 100 squared, 10 squared is 100. 2 times 13 times 10. That's 260. And then cos 100 is what you really need the calculator for. And if we plug that in, yes, we're going to get an absurd decimal. Minus 0.1736 dot dot dot. So if we put that all in, we get x squared is 314.1485, and we'll leave it there, dot dot dot. Okay, so we'll square root that on our calculator, and we're going to get x equals 17.724. We're going to round that to one decimal place, so that is going to be 17.7. And so x is going to be black 17.7. Cool. Easy enough. And it's sort of, and also it's a useful thing to check your answer. Does this number sort of make sense in the context of the question? Like if I work this out and I got x to be 10,000, I've probably done something wrong because this is 13. Is this really going to be 10,000? But this being 17 makes sense. This is a bit longer than this and a bit longer than that. It makes sense for x to be 17.7, and so that's reassuring. But like I said, if you get a silly number, you can be sure that you've probably made a mistake and check your working again. Okay, let's go through one more example. Right, look at our final example here. Give you a chance to pause the video and give it a go. But here we're now trying to find the angle. We're trying to find the angle BAC. So just let me show you what angle that is. It's because A is in the middle, it's going to be this angle. BAC is this angle here. Okay, so So because our angle is this A, we want to take the 6.9 as our lowercase a. So cos A is going to be equal to, we'll have B equals 5.2, C equals 7.3, and A is going to be the 6.9 because we're measuring this angle, which is opposite. Okay, so cos A is going to be 5.2 squared, add 7.3 squared minus 6.9 squared all over 2 times BC, so 2 times 5.2 times 7.3. And now I have my calculator right with me. So 5.2 so put all this in. When you do that, you should get cos A is equal to, so I'm going to express it as a fraction, 409 over 949. Equivalently, this is 0.4309789, so on and so forth. Or that might be it. And then we're going to use the inverse function. So we're going to use the cos minus 1 function on our calculator to figure out the angle. So cos minus 1 of 409 over 949. I always recommend using fractions in these calculations. There's far few numbers to write, and you know you're getting the exact thing. So when you do that, when you put that in your calculator, cos minus 1, 409 over 949, you get A equals 64.47023.185 degrees, and they would like it to 3 significant figures. So take 64.5. We round up because of the 7. The 7 here is bigger than a 5. And let's just check to see if that makes sense. 64.5 degrees. Yeah, looks about right, doesn't it? Looks about right. So, cool. Thank you for watching. Any questions, please let me know in the comments. And I'll see you in the next one.